Hi everyone, I'm going to take you through my review for our Unit 4 exam, which is going to be on Monday. So make sure you can do every single one of these problems. So my plan is to quickly show you how we can approach these problems. The first two are just adding and subtracting polynomials. If you take a look at this first one, when you have a subtraction, you have to remember you're subtracting the entire quantity. So to eliminate the parentheses, just change everything to its opposite. So if you notice here, I have this positive 6, now it's a negative 6. This positive 6a squared is a negative 6a, and it's a matter when you eliminate the parentheses, you combine like terms. Definition of a like term, same variable, same exponent. So 7 of the a squareds minus 6a squared gives you the 1a squared. And then this minus 7a, all by itself, I just bring it down, and I can combine my numbers, and I get negative 13. So this is in standard form, and that's all you can do with this problem. Second problem, we are adding polynomials. So really the parentheses are doing absolutely nothing. I don't have to worry about changing everything to its opposite since it's just a plus sign here. Combine your like terms. Start with the largest exponent. So right here I have negative k to the fourth plus 5k to the fourth. That's how I got the 4k to the fourth. If you look at your k cubes, I have 4 of them here. I have minus 6k cubed. 4 minus 6 is negative 2. And remember, the variable and the exponent stays the same when you combine like terms. So don't confuse adding and subtracting with multiplying. So here, the last term is just a 5k squared. We do not have any other 5k squared or the k squareds, so it just comes down. Again, this is in standard form. Okay, number 3, we are squaring a binomial. So one way of doing this is just write out the problem twice. 5x plus 4 times 5x plus 4, and you do FOIL. There is a shortcut. With enough practice, you can probably eliminate this step and get your answer. Your answer is always going to be a trinomial. So if you do FOIL, that's where the 5x and the 5x gave me the 25x squared. My outers, I get a 20x. My inside, I get a 20x. Together, I get a 40x. So you combine like terms there. And then 4 times 4 is 16. Do not be tempted to say 8 there. 4 times 4 is 16. So make sure you have 25x squared plus 40x plus 16. Number 4 is the same. Make sure you have the 3r minus 4 times 3r minus 4. Notice a couple people on their quiz, you confused it with another concept and you changed one of the signs to a plus. That's not what we're doing here. When you do FOIL on here, you get a trinomial. Your outers and inners are both negative 12r. Together, you get this negative 24r. And remember, this last term will always be positive. A negative 4 times a negative 4 is positive 16. So again, check your answer here. And then when you have to take a binomial times a trinomial, this is where you have to be careful with your work. I am going to distribute the 8n. 8n times 7n squared is 56n cubed. The 8n times negative n is the negative 8n squared. And then 8n times 4 is the 32n. So I have to distribute the 8n, and then I'm still not finished. I have to distribute the 5. 5 times 7n squared is the 35n squared. 5 times negative n is negative 5n. And 5 times 4 is 20. All we have to do yet is simplify. You combine your like terms. So negative 8n squared plus 35n squared, that gives you 27n squared. And then my n's combined to give me 27n. So here's your final answer. This is something that I need to make sure everyone can do. A binomial times a trinomial, you're distributing twice. Okay? The next two, we're simplifying. And the key to simplifying a rational expression is to factor. You can only cancel out factors, not terms. So I try to remind you of that right here. So what it means is you need to factor this top part. I notice I have a trinomial. Chances are I'm going to be able to just simply do the reverse of FOIL. So start out with 2 sets of parentheses. You're locked into the k and k. And then the next clue is you're going to look at this negative 5. That tells you that your signs have to be different. So plus and a minus. And then really only one way of getting a 5, 5 times 1, but I must put the 5 next to a plus so that my outers and inners add up to this 4K. So that checks. I factored the numerator correctly. In the denominator, you need to think of GCF. So most likely, most of you are going to just factor out an 8, and you're going to be left with a 1 minus k. Now, that's the case where they're not quite the same. We need to change one of them to its opposites. So really, the key to this problem is to factor out a negative 8, which will give you the negative 1 that you're going to have up here, and it'll give you the positive k so that this and this will cancel out. And you're left with k plus 5 all over negative 8. So again, that's a little tricky when you have to factor out a negative, but just be aware of it. Okay, number 7, I have a trinomial over a trinomial. The nice thing about these problems, there's just a 1 in front. My leading coefficient is a 1, so it makes it pretty easy to factor. You're locked in this case, v and v. I'm locked in to, since a positive 15, my signs have to be the same. My middle term is also positive, so I'm going to have plus plus. Ways of getting 15, 15 and 1 won't work, but the 3 and 5 will, so that my outers and inners add up to the 8v. So I factored the numerator correctly. The denominator, v and v, I notice a negative 24, so my signs have to be different. I need to come up with a method of taking two numbers that will give me 24, but at the same time add up to a negative 5. So hopefully with a little bit of time, you're going to think of 3 times 8 is 24, and if I put the 8 next to the negative or the minus, my outers and inners will add up to the negative 5. So again, it's important to check by FOIL. So if it checks by FOIL, you know you factored correctly. Here we have the v plus 3 in common between the numerator and denominator. What's left over is my simplified answer. So that's all we're doing when we're simplifying a rational expression. Okay, this next page I know can be confusing for a lot of you because we're simply told to factor. And we learned several different types of factoring, so it's going to be your job to be able to distinguish what way we should factor. So here's a clue. If you see 4 terms and you do not see a GCF, there's nothing that's in common other than a 1, then divide the problem in half. It's set up for grouping. And so we're going to factor by grouping by factoring out the GCF of the first half. So what goes into a 3 and 18? Hey, a 3 is the largest. You also have a variable in common, so I can factor out, in this case, an x squared. So I put a 3x squared on the outside, x plus 6 inside. When you go over to the other side, we need to see this x plus 6. If we do not, we messed up somewhere. So the nice thing about this part, the only thing I can factor out is a positive 1. So this is really technically a positive 1 that's on the outside. And then in parentheses, I'm left with my x plus 6. So whenever you see this, you know you did this problem correctly. The pieces on the outside make up the 1 factor. The binomial that's inside the parentheses will make up your other. And just remember, this checks by FOIL. So when you use this method of factoring by grouping, take a second to quickly check by FOIL. 3x squared times x, that gives you the 3x cubed. The 3x squared times 6 is the 18x squared. The outers will check. My inners, 1 times x is just x, and finally 1 times 6 checks with the 6. So always check by FOIL method to see if you did this correctly. Number 9, same thing. I see 4 terms. I'm going to divide it in half. I'm going to figure out what goes into a 10 and 15. It's a 5. My letter that's in common, my variable, I have an n squared that I can take out. Inside, I'm left with 2n plus 3. On the other side, I see a negative. So whenever you see a negative, you need to factor out a negative. And then the GCF of 14 and 21 is a 7. So when I factor out a negative 7, I'm going to be left with the 2n plus 3. So I know I did this correctly. The pieces on the outside make up your 1 answer. The 2n plus 3 will make up the other factor. And again, check by FOIL. Okay, number 10, I see that I have a trinomial. Now, the first thing you always want to look for, make the problem so much easier if I can simplify it by factoring out a GCF. Hopefully, you're going to notice a 4, a 24, and a 28 are all divisible by 4. So I can factor out a 4 first. So I put a 4 on the outside. If I factor out a 4 from here, I'm just left with the m squared. Factor out a 4 from the negative 24, I have a negative 6 or a minus 6m inside. And then finally, factor out a 4 from the negative 28, I have a negative 7. Now, we're still not finished, but it's a lot easier now. We just keep the 4 on the outside. This 4 is going to stay where it's at on the outside. I'll start out with 2 sets of parentheses. I'm already locked in at m and m. That's the only way you're going to get an m squared. It's a negative 7, so I need minus and a plus. My signs have to be different. To be able to get a negative 6, that's why I put the 7 next to the negative and the 1 next to the positive, so that my outers and inners will add up to this negative 6m. So that checks. Number 11, if you're left with 2 terms, a lot of times students panic, they have no clue what to do when they just see 2 terms. People seem to be fine with factoring by grouping when you see the 2 terms on the one side. It's the same thing here. So all you have to do when you see 2 terms, and it's not a special case like the difference of perfect squares, look for the largest value that you can factor out. So in this case, a 3 and 15, I can factor out a 3. I have a variable in common, so I can factor out the smallest exponent, which in this case is m squared. So I put a 3m on the outside. What's going to be left inside, the reverse of the distributive property, I'm going to be left with an m and a plus 5. If you check by the distributive property, you're back to your original. You know you did that correctly. So please check by multiplying. Anytime you factor, check by multiplying. You should get back to your original problem. Okay, number 12, another case where I can factor out a GCF. And so the only thing in common is a 1k. So I put a k on the outside. If I factor out a k from the 7k squared, I'm left with 7k. When I factor a k from a k divided by k is just a 1. It checks by the distributive property. Okay, number 13, we have a trinomial. Now, what makes this problem a little bit tougher is the fact that I have a 2 as my leading coefficient, and I can't factor out a 2. 2 doesn't fit into the 15 and the 7, so that's where we learn that AC method. More systematic approach to being able to find the factors. So if you take 2 times 7, you're going to get 14, and then I need to look at this middle term. I need to think of factors of 14 that can add up to that middle term. So I can replace the 15a with an equivalent expression, the 14a plus 1a. That adds up to 15a. It's the factors of 14. And then if I divide and factor by grouping, you're going to see that we did this correctly. When I factor out a 2a, I'm left with the a plus 7. On this side, I can only factor out the 1, but I see the a plus 7. My answer, what's outside, 2a plus 1 and the a plus 7. Now, once again, just check by FOIL. If you do a quick little mental check, outers, inners will add up to that 15a. 1 times 7 is 7. It checks. Okay, the next type. Now, if you're exposed to these, if you recognize a perfect square, and you should know your perfect squares, 1, 4, 9, 16, 25, so on. You see a perfect square minus a perfect square. Start out with 2 sets of parentheses. To get a negative, the signs have to be different. And the nice thing is there's no guesswork. I take the square root of 9b squared, I get 3b. So I need a 3b times 3b, that's the 9b squared. I take the square root of 25. I don't have to sit here thinking of factors of 25. I just take the square root. 5 times 5 is 25. And the nice thing about this, the reason we don't see a middle term is because the outers and inners are opposites. You get 0.